In this video, we will look at how to implement the catenary form finding example in Mobius. In the form finding example, the positions in a polygon grid are modified based on the forces exerted by an upward force and by neighbouring positions. The process results in a variety of catenary dome forms. The flowchart has 5 parameters. The first is the rest length of all the edges. The second is the stiffness factor of the edges. The third is the upward force. The fourth is the number of iterations. And the final parameter is the type of roof, square or round. As with the previous example, we will again focus on the code in the solver node. In general, you will see that overall structure of the code is very similar to the previous example, the minimize detours example. Although the 3D model is completely different, the solver algorithm is actually similar. As before, the solver has 4 main steps. The only step that is a bit different from before is step 2. We will explain it in more detail later. As before, step 3 loops over all the positions and applies some sub-steps. In this case there are 2 rather than 3 sub-steps. The middle sub-step form, the minimize detours example, has been removed. Let's look at the code to see what is happening. The first step is exactly the same as the previous minimize detours example. The XYZ coordinates and indexes of the fixed positions are retrieved. The second step is different. In the minimize detours example, the neighbouring positions could change each time step. The neighbours were therefore recalculated each time. However, in this example, the neighbours never change. Neighbours can therefore be calculated one time and stored in a data structure for later retrieval. The data structure is simply a list of lists. Notice the expression that is used to navigate from one position, via a set of edges, to all neighbouring positions. In the expression, POSIS is a list of positions and PI is the position index. Next, the 2 nested loops in the solver are the same as the previous minimize detours example. And the check for fixed points is also the same. The process of modifying the XYZ coordinates is also similar. But the way of calculating the magnitude of the force vectors is different. In this case, the force magnitude is equal to the deformation multiplied by the stiffness. And the deformation is the difference between the new length and the rest length. As before, the force vectors for all the neighbours are added up, creating a final cumulative force vector. This vector is then used to generate modified XYZ coordinates of the position. These coordinates are saved in the temporary list. The last step is also exactly the same as the previous minimize detours example. The modified XYZ coordinates are used to update the position entities in the geometric model. Finally, here we can see some of the results from executing the solver for varying numbers of iterations. As the number of iterations increases, we can see the roof being pushed further upwards.